Hello students, this is our fourth lecture of lecture series of STMJ 241 continuous probability distributions and sampling distributions. Topic of this lecture is M.G.F and C.G.F. Let's start the session. Form of this M.G.F is moment generating function. Its full form is moment generating function. Moment generating function. As on its name, the purpose of this function, moment generating function, is it helps to generate the moments any random variable. It is defined as usual for discrete also and continuous also. Let's see its definition. If x is any continuous random variable, then mx of t, its PDF fx, if is fx, then mxt is defined as expectation of e raised to x. Okay, x हा कंटिन्युअस रँडम व्हेरिएबल आहे. एक्स PDF आहे कंटिन्युअस रँडम व्हेरिएबलसाठी. mxt हे अशा पद्धतीने डिफाइन केले. xt is equal to expectation of e raised to x. It is nothing but how to solve this integration is to tx fx over x. What is the purpose of this MGF is, as we just discussed, it helps to generate the moment generating function. It helps to generate the moments. How? Suppose for any continuous random variable you obtain this MGF. There are two ways. The first is expand MGF. Expand this st, and in the you will get the raw moments from this MGF. How? They are coefficients of e raised to r upon r factorial, the expansion of xt. काय करायचं आहे, जो काही MGF आहे, एखाद्या कंटिन्युअस रँडम व्हेरिएबलसाठी MGF आधी ऑब्टेन करायचा, त्याचं एक्सपान्शन करायचं. एक्सपान्शन केल्यानंतर टी रेस टू आर अपॉन आर फॅक्टोरियलचे जे काही कोएफिशियंट असतील ते म्हणजे आपले रॉ मोमेंट्स असतात. And once you get the raw moments, there are some relations between the raw moments and central moments. And obtain by using those relation central moments. This is the one way, and another way is by differentiation. Another way is differentiation. So mu r dash is nothing but e raised to r upon expansion of. तर तुम्हाला mu1 dash हवा असेल, want mu1 dash, differentiate mxt once, and whatever the derivative you will get, put the value of t is equal to 0 derivative. All answer will be your डेरिव्हेटिव्ह घ्यायचे. mxt चा डेरिव्हेटिव्ह घ्यायचा. जो काही डेरिव्हेटिव्ह मिळेल त्या डेरिव्हेटिव्ह मध्ये टी ची व्हॅल्यू 0 पुट करायची, ते सॉल्व्ह करायचं, मला mu1 dash ची व्हॅल्यू मिळेल. अशाच पद्धतीने u2 dash काढायचं असेल तर टेक द सेकंड डेरिव्हेटिव्ह, तो सेकंड डेरिव्हेटिव्ह सॉल्व्ह करा, टी ची व्हॅल्यू 0 पुट करा, मला मिळेल. The same way you will get the mu r dash. This is the uh, application, or this is the purpose of actually this M.G.F. With the help of that, you can obtain the raw moment. Let's see one example where we will obtain this raw moments and central moment actually. Suppose this fx is PDF 2 into e raised to minus 2x, x greater than or equals to 0, 0. Next, find M.G.F and hence find raw moments and hence find raw moments and other moments. Okay. And once you obtain the raw moments and central moment, you can interpret about the nature of the distribution. Let's see the solution. Here fx is 2 into e raised to minus 2x. This is positive. Use the definition of M.G.F. Definition of e raised to integration from minus infinity, lower limit is 0 to infinity, that is to t, x is e raised to. Okay, त्यानंतर स्टेप सॉल्व करायची. Now solve this. Take 2 outside the integration. Minus. Take minus sign outside. 2 t. याची अरेंजमेंट काय केली आपण, कारण की आपल्याकडे एक फॉर्म्युला आहे. वी हॅव द फॉर्म्युला integration from 0 to raised to x raised to minus 1 dx raised to gamma n raised to n. Here it is 2 times a is 2 minus t. A is t and n is x raised to 0. N minus 1 is 0, so n is n minus 1 is 0, so n is 1. Gamma 1 is 1 upon 2 minus 2 a raised to n. That's it. All this gamma 1 is 1, 2 upon 2 minus 2. Take this 2 outside. 1 minus t upon. To get cancel, you will get mx of t is 1 upon 1 minus, and write this simply 1 minus t upon 2 is 2. This is the M.G.F. Now the question is, once you obtain this M.G.F, using this M.G.F find raw moments and central moments. Okay, so now this is the M.G.F. Expand this M.G.F. Now there is one series 1 upon 1 minus x. Minus x is equals to 1 plus x plus x square plus x cube is 2, so on. To solve this by expanding of expanding mxt, what do we get? 1 plus x. What is x? P by 2 plus square plus and so on. Okay. What is the concept? Concept is after expanding the mu r dash, nothing but coefficient of t raised to r upon r factorial, the expansion of mxt. Expansion of mx. Mu1 dash is what? This is coefficient of t, the expansion of mxt. What you will get? The coefficient of t here, it is 1 upon 2. Similarly, you can obtain mu2 dash, which is equals to coefficient of t square upon 2 factorial. 2 factorial is nothing but 2. What do you get? Here it is t. You observe this. This is t square and 2 square, that is 4. So 4 you can write like this. So the coefficient of t square upon 2 factorial is again it is 1 upon 2. Mu3 dash, this is coefficient of t cube upon 3 factorial, nothing but coefficient of t cube upon 6. Okay. So what is this? If you observe here, it is t cube upon 2 cube is 8. Take this 8 outside here. T cube, to make the adjustment of this t cube upon 6, multiply by 6 and divide by 6. The coefficient of t cube upon 6 is nothing but 6 upon 8. That is mu4 dash. Again the coefficient of e raised to 4 upon 4 factorial, but is to 4 upon 24. Okay. The expansion of xt. या ठिकाणी बघा टी रेस टू 4 अपॉन 24 चे ऍडजस्टमेंट करण्यासाठी या ठिकाणी काय आहे? टी रेस टू 4 अपॉन 2 रेस टू 4 म्हणजे 16. 24 ने या ठिकाणी मल्टिप्लाय करूया, डिवाइड करूया. या ठिकाणी कोएफिशिएंट असं होऊन जाईल 24 by 16. इट इज 3 by is 24. त्या पद्धतीने आपल्याला mu1 dash, mu2 dash, mu3 dash, mu4 dash raw moments मिळाले. So you can obtain the central moments by using the relations between raw moments and central moments. mu1 is 0, mu2 is equals to 2 dash minus mu1. mu2 dash आहे 1 upon 2 minus mu1 dash आहे mu1 dash पण 1 upon 1 upon 2 minus 1 by 4. mu3 equals to mu3 dash times mu2 1 dash plus 2 times mu1 dash cube. All this mu3 dash is 3 by 4 minus 3 times mu2 dash. mu2 dash and mu1 dash is same, 1 by 2 into plus 2 into mu1 dash cube upon 2 cube is upon 8. Solve this is 3 by 4 minus by 4 plus 2 upon 8 means 1 by 3 by 4 get cancelled. 2 3 is 1 by 4 which is positive. So the interpretation is the distribution is therefore distribution is positively. Now obtain the next to 4 dash minus 4 times dash mu dash plus 6 times mu 2 dash 1 dash square plus minus 3 times dash mu 4 dash is 3 by 2 4 times mu 3 dash 3 by 4 mu 1 dash and mu 2 dash are 1 by 2 1 by 2. 6 mu again 1 by 2 square is 1 by 4. 3 multiplied by mu 1 dash by 2 cube 1 by 8. 4 get cancel 3 by 2 by 4 minus 3. This 3 by 2 minus 3 by 2 get cancelled. 3 by 4 minus 3 by 8. This is 8. It's minus 3. So mu 4 is 3 by. So already we have discussed about the coefficient of skewness. This the distribution is positively skewed. Let's discuss about the gamma 2. Beta 2 is mu 4 1. Mu 4 is 3 by 8. Mu 2 square is 1 by 4. 1 by 4 square is 1 upon 6 by 8. Gamma 2 is equals to beta 2 minus 3 minus positive. Therefore, the distribution is leptocrutic. काय शिकलो आपण या ठिकाणी MGF वरनं रॉ मोमेंट्स कसे काढायचे आणि सेंट्रल मोमेंट कसे काढायचे ते आपण पाहिलं. Now let's discuss some properties. Very first property and important property is mx of 0. So whenever it is asked, check whether the given the function mx of t is MGF or not. So check that we use this property. Just put the value of t is equal to 0 in the given MGF. Solve this. If you get mx of 0 is equal to 1, you can interpret that mx of 0 is equals to, you can interpret that the given mx of t is MGF. Very important property. Second is regarding the change of origin and scale. So x, if you change the origin, x plus b of t is equals to, you will get e raised to bt. Is a. Then you take mx by multiplication, change of scale, dx of t, you will get mx of, if you consider change of origin and scale both simultaneously, that is ax plus, it is e raised to bt and x of this way. This is the second property. Third property is if x and y are independent, x and y are dependent, then MGF of x plus y is equal to mx of t multiplied by y of t. Very important property, and this property we use in wherever it is asked to check the additive property of distribution. To prove the additive property for distributions, we use this concept or this property of MGF very much. Fourth one is uniqueness property. What is meant by this uniqueness property? That is, if x is any distribution, then its MGF will be unique. Okay. MGF is unique. And if something MGF is provided, it will identify any distribution uniquely for x. That's it. Okay. एखादं डिस्ट्रीब्यूशन आहे बायनोमियल कंटिन्युअस आहे म्हणून आपण कंटिन्युअस कन्सिडर करूया. इफ एक्स इज नॉर्मल डिस्ट्रीब्यूशन विथ पॅरामीटर 2, sigma square, then its MGF is e raised to mu t half square t. हे या डिस्ट्रीब्युशनसाठी एक युनिक MGF असेल. तर हे MGF दिलं तर तो युनिकली आयडेंटिफाय करेल की ते डिस्ट्रीब्युशन जे आहे ते नॉर्मलचंच असेल. जे हे MGF दोन वेगवेगळ्या डिस्ट्रीब्युशनसाठी MGF राहू शकत नाही. ओके, दॅट इज द युनिकनेस प्रॉपर्टी. नाउ these are the properties of MGF. Now the next concept is full form is cumulant generating function. Generating function. Again, the purpose is with this function we generate the cumulants. With the help of cumulants, there are the relation of these cumulants with central moments. So once you get the cumulants, you will get central moments. With the help of central moment, you can find out the coefficient of skewness and kurtosis. That's why you can interpret about the nature. That's it. So let's see the definition. C.G.F, it is denoted by kx of t. Suppose x is any continuous random variable with PDF fx kxt, it is obtained as log of x of t. Once you obtain the C.G.F with the help of these cumulants, with this cumulant generating function, you can obtain the cumulants. How? So suppose you get the kx of t. The cumulants, they are denoted by kr. Coefficients of e raised to r upon r factorial. Expansion of kx of सेम जसं आपण मोमेंट साठी केलं त्याच पद्धतीने MGF साठी केलं तसंच. लेट्स सी वन एक्झाम्पल. वरती जे आपण MGF मिळवलं for this fx, what MGF we get here? 1/1 minus t upon 2. त्याच MGF साठी आपण पुढे प्रोसीड करूया. PDF न घेता किंवा आपण डायरेक्ट MGFच असं कन्सिडर करूया. MXT आपल्याला दिलेला आहे. वरचं जे एक्झाम्पल आहे त्यासाठीच आपण क्युमुलंट्स काढतोय. 1 minus t upon 2 raised to minus 1. Question is find hence square. What is the definition of cumulants? Kx of t equals to log of t, log of minus 1, minus 1 side outside, minus log of t. Now there is one series. Use that series. Log of 1 minus x equals to minus outside x plus x square by 2 plus x cube by 3 is to 4 by 4 plus so on. ठीक आहे. तर ही सिरीज आपल्याला या ठिकाणी यूज करायची आहे. मायनस मायनस प्लस so log of 1 minus x is, take consider this as a x, t by 2 plus t square by 2 is 2 t cube, so this is 2 upon 2 cube, 2 cube is 8, 3 upon t raised to 4, 2 raised to 4 is 16, so on. So this is the cumulant generating function kx of t. What we define? Kr equal to coefficient of t raised to r upon r factor. The expansion of ऑलरेडी एक्सपान्शन आपण या ठिकाणी केलेलं आहे. k1 काय येईल? दिस इज k1 इज coefficient of is equals to 1 upon k1 is always raw moment mu1 dash, which is already we have computed that mu1 dash is upon k2. This is coefficient of t square upon factorial is equals to, that is t square upon 2 factorial means coefficient of t square upon 2. Okay. So if you compare here, the coefficient of t square upon 2 is 1 upon, which is nothing but mu2. So variance is this. Now k3 is coefficient of t cube upon 3 factorial is nothing but t cube upon factorial is 6 equals to, so here it is t cube upon 20, t cube upon 24, that t cube upon 4. You can make the adjustment of this t cube upon 24 as cube upon multiply by 6 outside like this, multiply by 6 and divide by 6. So t cube upon 6 coefficient is 6 upon 24, but 1 upon this. Now k4 is coefficient of t raised to 4 upon t raised to 4, 4 factorial means 24. Yes. So which is equals to, ठिकाणी काय बघा, t raised to 4 upon 64. ऍडजस्टमेंट कशी करायची? 64 इकडे आपल्याला काय हवंय? 24 ना. This way. So coefficient of t raised to 4 upon 24 is nothing but 24 upon 4. Answer is 3 upon 8. So k4 is 3 upon 8. म्यू वन म्यू टू म्यू थ्रीच्या व्हॅल्यू आधी आपण ज्या मिळवल्या त्या पहिल्या एक्झाम्पल सेट त्या झाल्या का ते चेक करून घेऊया. बघा म्यू वन इज 0 म्यू टू 1/4 म्यू थ्री इज 1/4. तर आपला काय मिळालं म्यू थ्री. येस म्यू थ्री इज ऑल्सो गेट 1/4. म्यू फोर काय मिळालं तर वरती तेच मिळायला पाहिजे बरं का वरच्या एक्झाम्पलला जे मिळाले तेच सगळं मिळायला पाहिजे. 3/8. ओके. हा K4 आहे म्यू फोर नाही. तो म्यू फोर इज म्यू फोर काय मिळालं वरती 3/8. There is one relation mu 4 is K4 plus K4 is 3/8 plus 3 times K2 is mu 2 is 1/2 1/2 square 3/8 plus 4 as it is. We'll see 9/8 तरी mu 4 आलेला आहे 3/8 आलेला आहे. Here it is minus. Yes. Minus काहीतरी चुक. Just 1 minute. There is one relation between the raw moment and central moment. The relation is just wait. Mu4 relation from Mu4 is equal to K4 plus 3 times K2 square. It is right actually. It is not minus. Mu4 is equal to K4 plus 3 times K2 square. K4 is 3/8 plus plus K2 means mu2. Mu2 is 1/2. 1/2 square is 1/8. 3/8 plus 3/4. If you take the LCM, 8 plus 9/8. It is 9/8. वरती काय आलेलं आहे Mu4? अरे just wait. K2 square. K2 काय आहे Mu2 1/2. Mu2 काय मिळालेलं आहे या ठिकाणी आपल्याला वरती Mu2 काय आहे म्यू टू 1/4. म्यू टू 1/4 आहे आणि इथं काय आलं 1/2. काहीतरी चुकलं ना मी इथं. जस्ट चेक हिअर. जस्ट वेट. कोएफिशियंट ऑफ टी स्क्वेअर अपॉन 2 फॅक्टोरियल. टी स्क्वेअर अपॉन 2. दिस इज 2 स्क्वेअर इज 4 हिअर. हां. हे चुकलं बघा या ठिकाणी. स्क्वेअर करताना टी स्क्वेअर अपॉन 4 हवा होता. मग हे या ठिकाणी पहा 4 झालं. हां. या ठिकाणी बघा काय झालं K2 इज 1/4 स्क्वेअर. झाले 16. पहिले 6 + 3 9/16. mu4 is equal to 9/16. It is correct here. mu4 is 9/16. वरती काय मिळालं होतं आपल्याला वरच्या एक्झाम्पलमध्ये mu4 सुद्धा तोच मिळाला असायला हवा. तो जर वरती वेगळा आहे तर ते पण ते त्या ठिकाणी चुकले. mu4 या ठिकाणी बघा 4 कॅल्क्युलेशन चुकले. mu4 तोच यायला पाहिजे. mu4 is 9/16 is correct. त्या ठिकाणी कॅल्क्युलेशन्स बघा. upon 2 minus this, try to get cancel 3/4 by 8. Something calculation is wrong here. mu4 is not 3/8, it is 9. Okay. हे दोघं कॅल्क्युलेशन मध्ये सेमच यायला पाहिजे. This 9/16 is calculation. Just take these calculations. mu4 is equal to 9/16. Put this value here. For beta 2 सुद्धा चेंज होईल या ठिकाणी 9/16. Gamma 2 is equal to z. जस्ट कॅल्क्युलेशन आहे. थोडं एकदा तुम्हाला चेक करून घ्या. What we discussed here, students? We discussed the main two concepts M.G.F and C.G.F and the basis of M.G.F and C.G.F, how to obtain the moments, cumulants, central moments, and how to interpret about the nature of the distribution. That all things we have done and we have discussed in this lecture. For today, we stop here. The next lecture we will discuss the next part, mode, median, quartiles, and the Jacobian transformation. So the next lecture will be the last lecture of the first chapter, numeric continuous probability. For today, we stop here. Thank you.